Let's go through the code 3008. Find beautiful indexes in given array 2. For this question, it gives us a string S and string A and B. And for this part, you see that it's trying to find the string, the index of I, which have the match string S A, right? And also, we are trying to find the index of J, which has string matches B, right? So for every matched I, if we can find there exists some kind of J which have the absolute distance between I and J smaller or equal to K, then we'll say this is a beautiful I, and it is a beautiful index. So let's return the beautiful index array, list, right? So let's look at the example. You'll see this is a source string, and we're trying to match my, right? So there is my here, and also there is my here, right? So that one is 16, one is 33, and the B is squirrel, right? Squirrel, you'll see this one. This one is 18, right? This is 18. Actually, the absolute value between 16 and 18 is smaller than 15, right? So I said this 16 is a beautiful array. And also 18, we can use a squirrel here as the first squirrel as well, right? You know what, whatever. So we'll say the 33 and 18, the absolute value is also smaller or equal to 15. So that is also a beautiful index. So trying to find out all of the I index, which is beautiful. And there is K range 5 to the power fifths, and also A and B length range 5 to the power fifths. So what we're thinking about is that we create two lists, A list, which is the matching index for A, right? S matching index for A, and also B list, which is the match index of the B, right? And after intuitively, we find these two lists. Then we do trying to see whether this kind of index is in I match the meet I can find a J which has the absolute value smaller or equal to K, right? So to do the string matching, of course we can have the string index though, right? But that the length is 5 to the 50, 5 to the power fifth. So what we're thinking about is that we need to have some efficient way to find the index as matches A and B, right? So there are, we can do KMP or rolling hash, right? Rolling hash, we will calculate for A hash code, and we have keep our window size the length as A, right? Trying to see the hash code equals to A's hash code, target hash code, right? But the thing is that if we have a hash code equals, does not mean that these two strings are equal. It may have the hash collision. So we need to compare the substring from index I to see it really equals to A or not, right? But the thing is that to find the match index, there is another way we can do that, is that we can use the Z algorithm. So what do we do Z algorithm is that the things that the Z algorithm is, for example, there is the S, right? S, and we are going to create an Z array. So its length will be same of the string length, right? So for Zi, it represents from this index I this kind of character. What's the length? It matches from the beginning of S. So for example, we have A, B, C, right? And for example, this is D, right? And there is A, B, C. For example, there is E, right? So we know this kind of ZI should be equals to 3, right? If we use a brute force to create this kind of ZI, it will still it will be O S length multiplied by A length time complexity, right? So it's not better than brute force. But the advantage of the algorithm is that we know if we have this kind of match, for example, ABC, right? Let's change this one to be AAC, and this one also be AAC, right? So if we match this kind of box, if we go to this I, right? This I go to this index, we know this string is the same as the prefix, this part, right? So that means this we know this character, they should be equal, right? Because we already have this kind of box, the box, right? That means this kind of string equals a prefix, have the length of the box, right? So we know this character is the same as this character, and this kind of that is I minus L, right? We use the left and right to keep track of the box. So the I minus L we already calculate. So if this is the I minus L does not exist this kind of right bound, then we'll say this is the I should be equals to the I minus L, right? But if it exceeds, it's more than this kind of right bound, we will say we didn't compare those parts yet, right? So we still need to compare one by one, right? But when we compare this kind of character whether they're equal or not, we can extend the right bound of the box, right? And also when we compare, let's have the left bound to be I. So in this case, what we said is this kind of part of calculation matchings, right? So we'll say the ZI, it will at least extend to this kind of range, right? So we'll say that the box itself is like a sliding window. We'll see it will never go back. And its left bound, right bound is both going more forward. So the matching algorithm, it is O(n) time complexity. So let's begin to write code for this. We are going to use the Z-box, Z algorithm to write the matching function, right? So we are going to have the list get match. So we are going to have a string S and the string pattern. And what we do is that let's have this P in create a new string, have the P put P be in front of S, so that because the Z algorithm is always matching the prefix. So we're going to have a string, for example, str equals P plus S, right? So we are going, and also let's convert this one to array. Array equals str to array. So we are going to have int n equals array dot length, and let's use the left variable to be the left bound of the Z box, and the right variable to the right bound of the Z box. So and also we need to going to create a Z array because new int n. So what we do is that for int I equals to 1, I smaller than n I plus plus, right? So let's say zi, because we need this one to be not negative, so I'll have max 0. And also let's say we are not sure because of the we can only conclude that to the right bound of the box that the zi value determined to that to the right bound. We cannot determine any further, right? So what we'll say it will be mass dot mean the I minus left, and also that the right bound is because with that is length, right? So we are minus I plus 1, right? So so this is so this is the first one, right? So that the second one is that whether we can extend, right? So we'll have while loop y, right? While z I plus the I, right? Smaller than n, right? So that means that if we say if this I minus left is smaller than this prefix the right end, right? So it will not extend will not go to this while loop. So what we go for this while loop is that we're trying to compare array zi equals array I plus zi, right? If this equals, right, means our we'll need to resize our z box, right? Our right boundary is extending, right? In the meanwhile, we can have the left bound to be I as well, right? For this one, right equals I plus zi, and also we are going to have zi extend 1 unit, right? So what we do is that if I greater equal to m, let's have m equals p dot length, right? And p dot length. So that means we are matching because we have p in front of the s, right? So that means we match this kind of pattern in the s part, right? So if I greater equal to m, and also we'll have zi greater equal to m, then we'll have we needed to have a result, right? List the integer result for new array list. We'll have the result at I minus m, right? And in the end, we return result. Okay, so this is a string matching. Okay, and we need to. So we are going to have two lists. This integer a list equals get match as a, right? And we're going to have a list integer b list equals get match s and b, right? So that is all of the match index of a and b, right? So we are going to have also have a result equals new array list. Here, how can we find the index I, right? We can use the two pointers into I equals 0, j equals to 0, right? So what we say, while I is smaller than a list dot size, and j is smaller than b list dot size, right? So what we do is that we're going to have trying to see the index absolute difference, right? So if mass dot absolute value a list get I minus b list get j, if this one is smaller equal to k, right? So we are going to put this kind of index, right? So we'll have result at a list data. So let's say else if a else that is the absolute value of the index is greater than k, right? So there are two kind of scenarios. One is get I smaller than b list get j, right? Means a is too small, so I have I plus plus, and else that is in the other case is a list get I greater than b get j, right? So that means I is too bigger, right? So I have j plus plus, okay. And in the end, we just return result. So let's say, for this kind of match, so that is O S is, for example, this is the N, right? So this is O, for example, S length is N plus A length, right? A length. And this one, the time complex is O N plus B length, right? And here we have while loop, right? So that is also the let's say this kind of match index, right? So the size of A and size of B, right? They will never exceed more than ON, right? So the total time complex will be almost ON plus the max AL and BL. So that will be the time complexity. So here, the thing is that we also need to have I plus plus, okay? Otherwise it will not move. And we can convert this kind of code to Python code as well. So let's first have defined the get match function, get match. And what you need is we have string, right? So because that's the inner function, we don't need to pass in that. So we have p as pattern, okay? And it can return list int, right? So what we do is that we'll have a result equals this, right? So we'll say, and we'll have a source equals p plus s, right? And we're going to have n left and right equals length of source, and have left and right be 0, right? And we need to have z array equals this one multiplied by this, right? And we have m as well. M equals the length of p, okay? And we'll say for I in range from 1 to n, okay? And we'll say zi equals max, right? So that means it cannot be negative, and mean zi minus left, and also be the right minus I plus 1, right? And then we're going to have the while loop while I plus the I smaller than n, what's the end, right? And source the I equals source the I plus the I, right? So in this case we can extend the box, right? So we'll have we can also have the left boundary to be I, right boundary to be the I plus the I, right? And also we need to have the ZI extend by one, right? So what we do is that if this is I greater equal to M and the I also greater equal to M, right? We'll have a result append I minus M. So this is the way, right? The box to matching the string. So we'll have a list, right? A list equals get match S A. B list equals get match S B, right? And we need to have a result, right? Result equals this. And let's have an I J, right? That is two pointer 0, 0, right? So I say while I smaller than length A list and J smaller than length B list, right? So I say if absolute value A list I minus B list, and let's put all of this to be capital. B list J small equal to K, right? Then we'll result append A list I. And also we'll say I should move at least one, right? Remember a moment ago we have uh infinite loop in the Java code. So this will need at equal to one, right? So we'll say elif a list I smaller than B list J, right? That means I is too small. I'll increase I, right? So, we'll have else, right? Else J plus. And in the end, we just return result. Now, get match A list plus A list. It's just we already have an S, right? We don't need to pass in S anymore. So it should get this S. Not up arrow, get a match A, get a match define, get a match B list. Object is not subscribable. Object not subscribable. line 6 length SOURC. So function matrix is not subscribable. What does this mean? Actually, I'm not sure what does this mean, but yes. Should be this one. Should be this. This is get its length, right? So I think we can still have this, right? Should be fine. 0, 0. Yes. Just a list image. So let's say we for this in the defined function we didn't return the result yet, right? We need to return. Here we didn't return. So this is Python code.